Edge banding in its many forms has been the solution to covering the substrate of high-pressure laminate, thermally fused laminate, or wood veneer panels. This video will demonstrate differences in modern edge banding and legacy edge banding materials and processes. In the past, the only method to cover an edge of a panel was a process called self-edge. This legacy process includes cutting edge strips, gluing these strips to the edge of a panel, and lastly trimming and finishing the edges. Today, the self-edge banding process is being replaced by a modern edge banding process using a roll-type banding. Early on, the producers of roll edge banding were not able to keep up with the ever-changing color and pattern variations of the sheet goods manufacturers. The process of self-edging begins by slicing strips of banding from the original sheet of HPL or veneer used to face the component, and is often done by hand. These strips are then glued onto the edge of the panel using a contact adhesive. The adhesive is applied to both the banding strip and the edge of the component and allowed to dry per the manufacturer's specifications. Once dry, the two parts are bonded together. A roller is then used to apply sufficient pressure to ensure a solid bond. Following this, the edges are routed to remove excess material. The edge is then further finished using a hand file to remove any remaining sharp edges or burrs. As you can see, many factors have an impact on the success of a quality finished edge using the self-edge method: proper adhesive coverage, tack time, and skill of the finisher in filing to create a smooth transition from face to edge. Applying roll-type banding is easily accomplished by machine. Parts to be edge banded are fed into the machine on the left and are conveyed past a number of machining stations, each of which performs one step of the process. The pre-mill is the first station. A few thousandths of an inch of the edge of the part is removed. This allows a clean, fresh, and a flat edge to continue to the next station, which is preheat. The edge of the part is warmed just prior to the adhesive being applied. This helps the adhesive to coat evenly and to bond better. The adhesive is then applied to the edge of the part, and immediately the roll banding is placed on the leading edge of the part. Notice the banding is oversized to ensure the entire edge of the part is covered. It will be trimmed in subsequent steps. At this point, the roll banding has been lightly tacked to the part. The next series of stations securely affix the banding. This is accomplished when the part passes over rollers with increasing tension or pressure. Blocks may also be used for longer contact and to introduce air, which further sets the adhesive. With the banding now affixed to the edge, trimming and cleaning begins. At the next two stations, the leading edge and trailing edge excess banding is trimmed off. The part continues and passes through top and bottom trim routers, which, as implied, trim off the excess banding from the top and bottom edges of the part. The remainder of the stations buff and bevel the banding. The buffing step is required because roll banding edges turn white while being processed. The buffing station heats and polishes the banding, returning it back to the original color. Self-edge or roll banding? Well, there will always be an occasional need to self-edge. However, in today's construction and fabrication environments, most applications are better served with roll-type bandings. In any volume, the efficiency of the process reduces lead time and costs. The product is often better performing, longer lasting, easier to maintain without sacrificing a design match. The added bonus is the infamous brown line of plastic laminate that everyone hates is eliminated.